everyone, welcome back to No's Chem Corner. As you know, we are continuing the basic series. The topics you must know before you are going to take the AP Chemistry. The full playlist is linked right here, so you can catch up on any missed topic. In today's episode, we are going to deal with atoms, isotope, ions, and everything. The very basic aspects. Let's get started. Here you go. Atom. So, what is atom? It's a very basic aspects of chemistry. You can tell chemistry is the study of atoms and its properties, like elements and its properties. So, what is this atom? Okay, atom is the fundamental unit of element, right? In periodic table, we have some 118 elements are there, right? So far, we have 118 elements. So, these elements are composed of their particular atom. Okay, their building blocks are called atom. Suppose you are taking, see, for example, lithium atom, lithium metal. In peripherally, you can see like this. Okay, so this element, when we are taking some sophisticated microscopes, you can see something is repeating. Correct? See the ball? Something is repeating. So this repeating unit is what we called atom. Right? This repeating unit is what we called atom. All the elemental properties are actually based on this atom structure. Okay. So what do you mean by atom structure? What are the subatomic particles? If you cut atom, what are the particles you can see? Basically, atom contain a nucleus and electrons surrounding them. Okay. So what are the particles inside the nucleus? Is there any particle inside the nucleus? Yes. Inside the nucleus, we can see neutron as well as proton. So, atom is composed of electron, neutron, proton. These are the subatomic particles. You can see these particles inside an atom. Okay. So, let's see what are the specialities of these particles. Okay. First one is proton. Proton you can symbolize like P or P plus. Why P positive? Because the charge is 1 positive. Okay. And neutron is chargeless, it's neutral. So 0 is the charge. So you can represent like N or N0. The next one is electron. Electron, the charge, as you know, it's negative charged species and E negative. Okay. Then what are the mass of these things? Okay. Proton having a mass 1.007 AMU. What do you mean by AMU? That is called the atomic mass unit. What it is? Atomic mass unit. So what do you mean by atomic mass unit? Which is a very small unit, because when you compare it to a gram, these mass are very low. Proton, neutron, electron mass is very low. So gram we can't use. So for convenience we are using a very lower unit. Okay. Actually speaking, 6.022 times 10 to the power of 23. You may be familiar with this number. This is 1 mole. Correct? So this number, this many AMU are constituting 1 gram. So see, such a low unit is this one. Okay. So 1.007 AMU is the mass of proton. Neutron is also around the same, like 1.008. But electron is, do not want to study the number, just negligible. Okay. So you can consider like electron mass is negligible. Clear? And as you know, the locations, protons, neutrons are in inside the nucleus, and electrons are revolving around the nucleus. Okay. Right. Then let's see. Then let me ask one thing. Suppose you are taking one oxygen atom. Okay. And when you open the oxygen atom, you can see some proton, neutron, electron. And when you are opening aluminum atom, you can see again some proton, neutron, electron. Are they same? Okay. If those are same, then what makes the aluminum atom different from that of the oxygen atom? Did you get the question? If it's same, then it should be identical, isn't it? Anything like that? Because atom is the constant unit, like atom makes the difference. If oxygen atom is different, like oxygen element is different from that of the aluminum atom, then definitely their atom should be different. Correct? Then only they can behave like differently. Right? But the problem is what? when you are taking oxygen atom and you are observing the proton, neutron, electron, which is identical with the aluminum atoms, protons, neutron, electron, then what makes oxygen atom different from that of the aluminum atom? Okay. You may get the idea. The difference is not in their properties, like or proton is the same, like the mass is same, the charge is same, everything is same, it's identical, but the number is different, right? When you're taking oxygen atom, you can see only 8 protons, maybe 8 neutrons, maybe 8 electrons, but the aluminum atom contain 13 protons. That's the difference. Okay, that makes the difference between aluminum atom and oxygen atom. Clear? So you can say the identity of an element is the atomic number. Okay. So atomic number is what is called identity of an atom. It is basically the number of proton in a nucleus. Okay. And can I say it is equal to the number of electron? Because atoms are always neutral. As you know, proton is positive charge and neutron is chargeless. So how many protons are there? That much of electron should be there. So atomic number is simply the number of proton, and yeah, definitely it will be equal to the number of electrons in an atom. Be specific, in an atom only. Right? If atom gets charged, then it is not the equal. If atom gets charged means actually it's a wrong thing, because if the atom gets charged, then it will be no longer an atom, then we are called it's a ion, it's an ion then. Okay, so don't want to be any confusion. Atomic number is equal to the number of proton, and which is equal to the number of electron in an atom. Okay, right. Then the second thing is mass number. So what do you mean by mass number? In an atom, the mass contributing thing is protons and neutrons, correct? We already seen this one. See, in which electrons are negligible, protons and neutrons are contributing to the mass of an atom. Okay, so mass number, do not think it is the mass of an atom. No, it is not the mass of an atom, but it's a sum of protons, just mere numbers only. Sum of proton plus neutron is what we called mass number. Okay, right. Then how do you represent this one? For example, if I am writing oxygen and 8 is here and 16 is here, this is the representation of an atom. Okay, what does it mean? The bottom left is what we called atomic number, and the top left is what we called mass number. Okay, always have to represent the mass number at the top and the atomic number at the bottom. Clear? Okay. Then another representation is there, a hyphen notation. For example, element symbol we are writing like this and a hyphen, and we have to provide the number. What should be the number? Is it atomic number? No, it is mass number. So we can write the mass number here. Okay. Another example. So if I'm telling aluminum is 13, and if I'm writing 27 here, which means the number of proton is 13, the number of electron is also 13, and the number of neutron is what? 27 minus 13, which means 14. Okay, because mass number is the sum of protons and neutron. Okay, so 27 minus 30 will give the neutron number. Clear? Okay. Then the other thing is isotope. So what do you mean by isotope? Okay. For example, if I am telling I am taking 100 chlorine atom. Okay. What I am telling? 100 chlorine atom. Do you think all the chlorine atoms are identical? Isn't it? It's an element, right? Chlorine, the same chlorine element, and their own atoms, not any other element. We are not comparing any other element. So is it all the atoms of a same element are different or same? Ah, you may think it is same, it's identical, but actually it is not identical. Even you are taking the same element, all the atoms are not identical. Okay, if I am taking 100 chlorine atom, for example, the experimental evidence says that, see, 75.76 percentage of chlorine is look like 35 chlorine. Okay, so what is the percentage? 75 points. So 75.76 percentage. That many atoms are look like 35 chlorine, and the remaining percentage like 24.24 percentage is look like 37 chlorine. What's the difference? What do you mean by this 35 chlorine and 37? See how I represented the mass number. I'm talking about 35 and mass number is here is 37. Which means what is the difference? What is the number of protons and number of electrons and number of neutrons here? 30 for chlorine, you know, it's 17. So I'm writing the bottom is 17 because atomic number is 17. Okay. So can you compare these two? Oh, protons, you know, 17 protons. Here also 17 protons because atomic number is 17. Electron is also the same because it's an atom. 17, 17. And what about neutrons? See, it's 35 is here. Mass number is 35. So 35 minus 17. Okay. Similarly, 37 minus 17 is the neutron number. So neutron number is varied. Correct. So you can see a very neutron number. So that makes the difference. Okay. So in the same element, the atoms are different in terms of their neutron number. That's why when you are thinking about the atomic number, we are considering like identity of an element because atomic number will not change. Okay. Only the neutron number will change. Clear? So that's make the different atoms in the same element. That is what you mean by isotope. So you can say chlorine have two isotope. One is 35 chlorine and the other one is 37 chlorine, which means one contains 35 minus 17 neutrons and the other contains 37 minus 17 neutrons. Okay, that's it. Then the question is, what is the mass of this atom? So 35 atom, 35 like mass number chlorine, what may be the mass? It have a mass near 35, right? See, they were given exactly the 34.97 because you know proton is 1.007 and the other one is 1.008 like that. Okay, so the mass of this one is nearly 34, exactly 34.97 AMU, suppose. And the weight of this one is exactly 36.97 AMU. Okay. Then which mass I want to take? What is the chlorine actual mass? If I am doing some calculation, which mass I have to substitute? Either 34.97 or 36.97. You may think higher percentage is this 75.76, so you can take 34.97, or you may think you can take just average like 34.97 plus 36.97 divided by 2, right? Here we are doing a weighted average method. Okay, we can't consider like the just average. Just average means we are considering equal probability, equal percentage, correct? But here the percentage are different, so that's why we are taking average, weighted average atomic weight. Okay, that's the way of doing this one. Okay, so what do you mean by weighted average atomic mass? You can take the isotopic mass like 34.97 and have to multiply with their own natural abundance. So as I told you, 75.76 percentage is their natural abundance. So 75.76 divided percentage. So divided by 100 is there. So I can just write 0.7576. Okay. 0.7576 plus 36.97 times their own natural abundance, which is 0.2424. Okay, the fractional abundance we are taking. So this will give the actual atomic mass. That mass is what we are thinking like chlorine atomic mass. Okay, it's near to I think 35.45. Okay, that is the mass of element. So this is how we are taking all the atomic mass, taking atomic mass for all the elements, weighted average atomic mass. Why? Because of the presence of isotope. What do you mean by isotope? Different atoms of same element. Okay, different atoms of same element. Why they were different? Because of the difference in their neutron number. That makes difference in their mass. Clear? Okay. The last topic is ions. What do you mean by ions? As I told you, atoms are always neutral. Okay. If atoms is not neutral, then what we are called ions. Then how an atom get charged? See, you may think like nucleus is here and some positive charge is there and the electrons are revolving here. So you can make atom like charged by adding proton, isn't it? By adding proton or by adding some electron, isn't it? No, absolutely no. You can make atom get charged only by gaining or loss of electrons. Okay, proton is nuclear, like proton is like hiding in the like nucleus, right? It's a core of the thing. So while during the chemical reaction, there is no change happening for the nucleus. Got it? So you can get charge. Positive charge, you do not believe positive charge. How can an atom get a positive charge? Do not think some positive charge is added. No. Then electron removal is happening. Negative charge is losing. Negative charge is losing means the positive charge gaining. Correct? So always imagine you can make ion only in terms of electron. You can make ions only in terms of electrons. Electron, if you are added to an atom, what happened? Electron is added, negative charge is added. Correct? So you can say negative charged ion is formed. Clear? Negative ion. If electron is loose, negative charge is gone. Negative charge is gone means that much of positive charge you gain. Correct? So that is what you mean by cation. Cat is always positive, like that you can think. Cat is positive. Cation. And the other one is called anion. So these are the anion or cation. The charged species is what we called ion. How can an atom get charged? Yes, by adding or losing electrons. So you can think about a donation is always positive thing. Donation. So loss of electron donation is always making positive and cat positive. Okay. Donation is always a positive thing and cat is always a positive. Like that you can study that thing. Okay, so that is what you mean by ion. For example, if I am writing oxygen, I am again taking oxygen. Oxygen usual representation is 8 and 16 maybe the mass number, and this is the atom. Correct? So if I am writing 2 minus like this, what does it mean? Now it is not an atom, it is an ion. Okay, what's the number of protons? Number of proton is same 8. Number of electron, it's not 8 because now it is not an atom. So minus 2. So 2 extra electrons is added. Negative charge is the electrons present. So 2 extra negative charge electrons are there. So 10 electrons are there. And the number of neutron is 16 minus 8. Okay. So 8 neutrons are there. So this is how we have to do. So if charges are there, have to write right top. Okay. That's the way of representation of an ion. And that's it for today's video. If you found this helpful, give it a thumbs up and share it. Subscribe to Anu's Chem Corner for more videos. I will come back with another basic topic in next video.